This helicopter is named Ingenuity, seen here getting put through its paces in a test chamber at NASA's Jet Propulsion Lab. It's a little funny looking for a drone, but nothing too out of the ordinary. A more accurate description might be out of this world.
And liftoff as the countdown to Mars continues.
Now nestled snug up against the belly of the Mars 2020 Perseverance rover, Ingenuity is on final approach to Mars, where NASA hopes it will become the first aircraft to fly on another planet.
It's a game changer. It's something that will enhance space exploration, period, is the ability to fly around the planet.
The Ingenuity helicopter has the potential to really transform how we do science in other places around the solar system.
Mars changes the equation for flight with wings or rotors. The gravity is about 1/3 of Earth's, and the carbon dioxide atmosphere is much thinner.
It's about 1% compared to here, right, on Earth. Even though you're able to lift, right, you have to spin very fast to lift. Because the atmosphere is so thin, you can't lift as much mass.
Here on Earth, helicopter blades typically spin about 300 or 400 revolutions per minute. Ingenuity's blades spin about 8 times faster, 2,400 RPMs. The key challenge for the team, make the helicopter as small and light as possible to fit on Perseverance and to be flight-worthy. To find compact components, they didn't have to look much farther than their own smartphones.
The advancement of these cellular phone technologies and also, autonomous cars are also starting to have, reliable, lightweight sensors, right? And there are lightweight computers on the phones, and, drone community has also advanced electronic components.
Ingenuity is a technology demonstrator, so its goals are modest. The plan is to fly only 5 flights, no higher than 15 feet, no farther than 160 feet downrange, and no longer than a minute and a half. There are cameras aboard, and we may see some spectacular images, but the team is a lot more interested in performance data.
And I am notoriously guilty in how biased I am towards the engineering data, only because my goal is so much towards our helicopter Ingenuity data, feeding and informing, because ultimately we want to build much bigger, like true exploration aerial vehicles. And so that data is very important.
If history serves as a guide, Ingenuity could usher in a new era of mobile exploration on Mars.
We have imaging data. Yes.
In 1997, the first Mars rover, Sojourner, was also a technology demonstration project. The size of a microwave oven, it led to larger and more capable successors: Spirit and Opportunity in 2003, Curiosity in 2012, and now Perseverance.
A helicopter would actually allow us to access places that we can't get to with a rover, or even if we're going with humans in the future, which we are planning to do. The helicopters can actually help to do reconnaissance, to scope out a new site, or actually to access places that we can't actually access, to collect samples potentially, or carry scientific instrumentation to do some in situ science from the helicopter. So I think, again, will totally change the way we do science on the surface of Mars or other planets.
But baby steps first. Mimi Ong understands the historic potential of these test flights, and she and her team are committed to learn all they can.
It's been a long journey. I'm very goal-oriented. I want to get to learn as much as we can about flight. Think of Wright Brothers experiments, right? A whole series of experiments. At Mars, we just get to get one shot, right?
And speaking of shots, Perseverance will aim its cameras at Ingenuity when it flies. Another iconic image of a first flight awaits us. For the PBS NewsHour, I'm Miles O'Brien.